right, this is the second half of the rate of change and slope video where I'm going to show you how to use a table to calculate the rate of change or slope of a line. So this is, for some people, a little bit easier, some people a little more difficult. It depends on how visual you are of a person. So these just have the values in a table, but no graph to go along with them. So for some people, they don't prefer looking at an example like this. They like to actually see the graph. But unfortunately, you don't always have a graph unless you want to draw one. So I'm going to show you how to figure out the rate of change or slope using a table. So just a reminder, the rate of change is the ratio of the change between the y values and the change between the x values. So again, the biggest mistake people make is writing these upside down, flipping them around. And that's very easy, especially in a table like this, because if you see the x values are actually on top and the y values are on the bottom. So it's very easy to put your answer upside down because we're used to seeing x first and y second. So you have to just be careful about that. So when looking at a table, basically what you want to do is you just want to calculate the change between the x values and the y values. So I like to just kind of draw a little swoop and show underneath what's happening as you continue on in the table. So from 9 to 7, that's a change of -2. It's going down by 2. From 7 to 5, again, a change of -2. And from 5 to 3, again, a change of -2. Sometimes they are the same. They are not all the same all the time. I think just for the sake of keeping things simple, I gave you all examples where the change is constantly the same, just because this is just an introduction. If we look at the x values on top, -3 to -2 is actually an increase of 1. -2 to -1, again, it's an increase of 1, and then from -1 to 0 is an increase of 1. So what should happen is that you should get the same answers along the bottom and the top. So like all of these are +1s and all of these are -2s or -2s. That should happen. If it doesn't, either it's not a straight line or there's something else you have to do. But like I said, I'm going to keep it simple for you where they're all going to be the same. So then all you have to do after that is you have to take your answers and write them as a ratio. So remember, it's the change in the y values on top. So the change between my y values is -2, and the change between all my x values is a +1. So that means my ratio or my slope rate of change is -2 over 1, or if I simplify it, just -2. Okay, now this one we don't have to worry about units because there are no units in the table. So we don't have to worry about -2 what, we just write -2. So that's our answer. Let's look at a second example. Same thing, from 4 to 6, that's an increase of +2. 6 to 8, again, +2, it's going up 2. 8 to 10 goes up 2. 10 to 12 goes up 2. And then if we look at the x values, -4 to -2, that's also an increase of +2. -2 to 0, increase of 2. 0 to 2 goes up by 2, and 2 to 4, +2. So with this, we have actually the same on both for the change in the y and the change in the x. They're both +2. So the change in y is 2, the change in x is 2. 2 over 2 is a rate of change of just 1. Let's take a look at an example of a table that has some units involved, just so we can make sure we know how to incorporate those in our answer. Okay, this table is actually different. It's side by side, unlike the last tables we looked at. So if you remember, hopefully from way back in chapter 5, we did that, I think, in December. The x is always the column on the left, and the y coordinates are always the column on the right. So when we write our ratio answer, that's really important that we do the y's on top and the x's on the bottom. So the change between the y's, so from 24 to 36, that's an increase of 12 feet. From 36 to 48, also an increase of 12 feet, and from 48 to 60, an increase of 12 feet. The x-coordinate is representing time in seconds. From 6 to 8, that's an increase of plus 2 seconds. 8 to 10, that's an increase of plus 2. And 10 to 12 is also an increase of plus 2. Finally, all we need to do is write our answer as the change in the y values, which is 12 feet, over the change in the x values, which is 2 seconds, and then simplify. 12 divided by 2 is 6 feet per second. One question I get a lot about this is, can't I just divide to figure out the answer? And the answer to that is yes and no. If the relationship is proportional, then yes, you could just divide. If the relationship is not proportional, the answer is no, you cannot just divide. If you don't know if the relationship is proportional, then the best option is to figure out, kind of the way I just showed you right here, is to figure out the change between each of them and then write the ratio. If you did 24 divided by 6, you would get 4. If you did 36 divided by 8, you would get 4.5. 48 divided by 10 is 4.8, and 60 divided by 12 is 5. So if you remember from what we said about things being proportional, if all of those things aren't the same, then it's not a proportional relationship. That does not mean it's not linear. Things can still be a straight line without it being proportional. If it's not proportional, I'm going to write this down so you see. Not proportional does not mean it's not linear. All that means is that it does not go through the origin. Okay, so that just means that the graph starts somewhere else other than 0, which again doesn't mean it's not a straight line. It can still be a straight line and not start at 0. So you just have to be careful. Make sure you're following this new strategy. All right, I just wanted to throw this one example in here real quick, kind of just to show you a comparison. When we're talking about rate of change and slope, the point is to be able to compare different scenarios. So if you just take a look at, don't even worry about the questions that are over here. If you look at the two lines, red versus blue, you can see they both start at different points. Neither of them start at 0. So here, this is a perfect example of what I was just talking about. Neither of these start at 0. 0 is down here, but they're both still straight lines. So these are not proportional, but they are still linear because they're straight lines. You can see the red line is obviously, it starts higher, but it's less steep. The blue line starts lower, but it's steeper. So in this scenario, we're talking about gym memberships and which gym membership would you choose. It might seem like you would want to pick the blue one because it has a smaller starting fee at $40. But then the monthly cost for the blue one is actually way more than the red one because it's steeper. So it starts at 40, but then after 1 month, it goes from 40 all the way up to $160. So that's actually an increase of $120 in 1 month. The red line starts at $160, which is a lot as a sign-up fee, but after 1 month, it's only $200. So from $160 to $200, that's only $40 a month. That's a big difference. And if you plan on going long-term, then you would go with the one, obviously, that's cheaper per month, because as time goes on, that line is going to be cheaper because it's less steep. So you can see how figuring out the rate of change can be helpful in certain scenarios.